Hello friends, in last lecture we have discussed about image formations by different type of lenses, concave lens and convex lens. Today we will understand about sign convention for lenses, spherical lens. Also we will discuss about lens formula. We will also discuss about magnification by lenses and power of lens with some examples. Okay, so let's start from sign convention for spherical lenses. So sign convention for spherical lenses. The rules for sign convention for spherical lenses is same like mirror, that if it is at negative x-axis, if distance is at negative x-axis, so that will be negative. If it is at positive x-axis, so that will be positive in term of distance. Okay, and similarly if the object is placed, so its height, if it is above the principal axis or it can be below the principal axis. So if it is above the principal axis, means if it is below the principal axis, it will be negative, and if it is above the principal axis, it will be positive. Here we can say that we can understand it like this, that suppose here we are having this way. So now all of the distance is taken. Here we will have point of reference. In mirror we will have pole as a point of reference. Here the origin or point of reference will be considered as optical center. So here we will have our optical center, and when we place our lens like this, so according to that we have to find out the sign convention, the Cartesian sign convention. If it is in this direction, so it will be minus. If it is like this in right direction, it will be plus. If it is above the principal axis, it will be positive, and if it is below the principal axis, then it will be negative. So this way the sign convention is same as we have studied in mirror. Okay, also we must know that the convex lens, its focal length is always positive. Focal length of convex lens is always positive, and for concave lens our focal length, it will be always negative. Okay, so this will be our sign convention for spherical lenses. Okay, the second concept to understand, it is lens formula. As we have studied in mirror, that the formula which gives relation between u, v and f in mirror, so that will consider as mirror formula. So in lens, what it is the formula gives the relationship between object distance will be considered as u, image distance as v, and focal length f. So the formula which gives relation between object distance u, image distance v, and focal length f is called lens formula. How it is expressed? It is expressed like this: 1 upon v minus 1 upon u is equal to 1 upon f. Okay, so this will be our lens formula. Reciprocal of image distance minus reciprocal of object distance is equal to reciprocal of focal length. 1 upon v minus 1 upon u is equal to 1 upon f. Okay, then we will study about magnification, which is done by lenses. It is same as the magnification which is done in mirror. In that we have studied that what is magnification. Magnification is ratio of height of image to height of object. Similarly, it can be the ratio of image distance to object distance. Okay, so let's define it. So what it is the ratio of height of image, suppose that is h dash, and the height of object, if we consider it as h, right? So that will be called as magnification and is noted as non-capital N. So again, according to its definition, magnification M is equal to height of image h dash upon height of object h, or we can also write it is equal to v upon u for lens. For mirror it was negative, for mirror and for lens the magnification will be similar. Now same rules, that if magnification is positive, so our image it will be virtual. If magnification is negative, our image it will be real. Now we will have three possibilities for magnification. M will be equal to 1, M is greater than 1, and M is less than 1. In the case when M is equal to 1, it means our h dash will be equal to h, means height of image and height of object both will be same. If M is greater than 1, that means here h dash means our image will be greater than object, so that will give us the enlarged image. And here when M is less than 1, so in such case h dash is less than h. So in this case we will get our diminished image. So when M is equal to 1, we will get the same size of image. When M is greater than 1, we will get enlarged image, and when M is less than 1, we will get diminished image. Okay, now our topic is power of a lens. We know that lens can be of two types, concave and convex. Convex lens is converging lens while concave lens is diverging lens. So every lens will have two type of ability. It will have ability to converge or it will have ability to diverge. So what is power of lens? We can define it like this, that the ability, right? So the ability of a lens have only two abilities, to converge or to diverge. The ability of a lens to converge or diverge light rays is called power of lens. So the ability to converge light rays or to diverge light rays, that is considered as power of lens. Now we have seen that if the focal length is more, so its ability will get decreased. From that we can say that it is also defined as, the reciprocal of focal length. Okay, suppose if the power of lens is considered or noted as P, so it is defined as a reciprocal of focal length F. So power of lens will be equal to 1 by F. So this will be our formula for power of lens. Now whatever the power will be, right, it can be positive also or it can be negative also. It is depend on focal length. Okay, as we know that for concave and convex how the focal length will be, we know that for convex our focal length is positive and for concave our focal length is negative. So similarly for convex our power will be positive and for concave our power will be negative. Now what will be unit of this? So it is also very simple. Unit focal length, it is length, right? So it is measured in meter. So here we can have its unit like 1 upon meter, or we can also write it like this, meter inverse. If it is in centimeter, so centimeter inverse. And this is also called diopter, right? So it will be diopter, which is also noted as D. So from that we can say that P is equal to 1 by F. If we want this power as 1 diopter, so this must be also 1 meter. Okay, so 1 diopter is equal to 1 upon 1 meter. If the focal length of a lens is 1 meter, right, so in that case power of lens is considered as 1 diopter. Okay, so its unit will be meter inverse, or it is also called diopter. Let us understand some easy sums. Okay, so conceptual sums related to power of lens. Okay, here we are having one question. We have to find out power of concave lens. Keep that in our mind, that which type of lens is given. If it is convex lens, so our focal length will be positive. Here it is concave lens, so our focal length, it will be negative. Okay, and the focal length is given, that is 2 meter. So let's find it. F is given to us, that is 2 meter, but as it is of concave lens, so it will be negative. So our focal length will be minus 2 meter. Let's put out the formula of power of lens P. Power of lens P is equal to reciprocal of focal length. So P is equal to 1 upon F. RF is minus 2, so we can write it like this. It will be minus 1 by 2 will be equal to minus 0.5 minus 0.5. We can write unit as meter inverse, or we can also write it minus 0.5 diopter. So this minus shows us that our lens is concave lens. Let us consider another simple example. Similar, find the power of lens, but now we will take convex lens of focal length if we take it as 4 meter. So let's do. Here our f will be equal to 4 meter, but as it is convex lens, so f will be positive. So here we will consider f as positive. Apply the formula. Power of lens P is equal to reciprocal of focal length. So P is equal to 1 by f. From that we will get P is equal to 1 by 4. So from this we will get the answer. Power of lens P is equal to 0.25 meter inverse, or we can also write it that P power of lens is equal to 0.25 diopter, right? So this way we can calculate the sums which is related to power of lenses.